Hi there. So in this section, I'm providing you with a preview of solving polynomial and rational inequalities. And below here, I've written actual inequalities that we would be solving. I'm trying to figure out this inequality over here on the left. It's already in factor form. Where is that inequality greater than 0? And then over here on the right, where is this inequality greater than or equal to 0? And there's actually a correlation in terms of finding where these inequalities are greater than or equal to 0, and these just happen to both be greater than, but you could also be looking for less than, or equal to. There's a correlation between those functions and their graphs. And so before we get as far as what you see here in these particular equations here, I want to just take it back a step, okay? And let's just focus on the graph first. All right, so we're going to do example 1 here together. So here's the graph of your function, and it happens to correspond to this function up here, x plus 5 times x plus 1. And in part A, it wants to know, well, it wants us to use this graph to determine where our function here is less than 0. So let's come up here and look at the graph, and let's think about this. Remember, f of x is the same as x or y? If we agree, it's the same as your y. So I'm looking here, where are my y values less than 0? So think about your y-axis. Anything above the x-axis, anything above the x-axis is positive, anything below the x-axis is negative. So I'm just going to come over here and I'm just going to put some positive signs up here. So all of these, this portion of the graph up here are all positive. But down here below the x-axis, I'm putting some negatives down here because all of that down there below represents being negative. So in part A then, let's write our answers here in interval notation. Where is our graph? Where is our y less than 0? Where is it negative? And hopefully you agree that that's here between these two x-intercepts, between -5 and -1. And since it's less than, I'm using parentheses. Notice the subtle difference down here in letter B. Letter B says, well, where is my function or my y values less than or equal to 0? So basically it's the same increments, but this time I get to include the -5 and the -1, so therefore I get to put brackets on that -5 and -1, okay? Now in letter C, I'm asking where is my function greater than 0, or where are my y values greater than 0, where are my y values positive? So I want to come up here and choose intervals for where I have these plus signs. So the first one interval would be from -infinity to -5. Parentheses on both, and then pick up -1 to positive infinity. Parentheses on both, okay? And then likewise, the only difference in letter D is because here I'm saying that I want to actually be greater than or equal to 0, I get to put brackets on those x-intercepts. You know we can't on infinities, but we can on the x-intercepts. So it's essentially the same answer, but just put brackets on the -5 and -1, okay? All right, I encourage you, pause the video, kind of duplicate what I was just doing here in example 1 with example 2. If it helps you, write those pluses and minuses over here on the graph, okay? All right, I'm going to flip it on over, and let's look at now an alternative way, okay, which is actually more of the way that you'll be looking at solving these inequalities whenever we graph them or whenever we solve them in your Math 171 class. So what I want in example 3, it says solve the inequality, and so here's the inequality that you're looking at where it's greater than or equal to 0. So what that greater than or equal to 0 means is that it indicates that we're going to have brackets on our intervals, okay? And how do we decide our intervals? Well, I'm going to just draw a little quick number line here. Think about from before. Below the x-axis, these were your negatives. Above the x-axis, these are your positives. So you think about where the positive and the negatives get broken up. They get broken up at -2 and +2. And because those are closed circles and we're looking for greater than or equal to, then those would be brackets. I'm going to put closed circles here on our graph. And now what I want to do now is I just want to indicate these intervals now in my table down here below. So I want to indicate test intervals. So my test interval here would be from -infinity to -2. Then in between -2 and +2. Bracket on both. And then the last interval would go from 2 to infinity. bracket on the 2. Okay, that would be 3 separate pieces of that particular graph. Does that make sense? Okay, one or one or two of these individual test intervals will end up being a final solution for us. Okay, what our next step would be is that we would now choose an x value in each of these intervals. So I just need to choose something smaller than -2. I would just go with -3. I need to choose something then in the next interval between -2 and +2. If you can ever choose 0, I always say choose 0. And in the last interval, I need to choose something greater than +2. So let's choose a +3. Now I'm going to take these test values and plug them into your given function. So let me highlight that function for us so that it's kind of front and center for us. This is what I'm plugging it into. So everywhere I see an x on that first one, I am plugging in a -3. So I have a negative sitting out there, and then I have -3 + 2, and then I have -3 - 2. And we're just going to evaluate here. So I've got a negative. The first parenthesis turns into -1. Next parenthesis turns into a -5. And then if you do all of that multiplication, you land at a negative times a negative gives you a positive times another negative. So that's going to be a -5 for final answer. So you're going to see where all that I'm really interested in is, oh, that was a negative number. Okay. So I'm going to come up here, and on my number line that I've drawn for you, I'm going to say, okay, well, this interval corresponds to negative values. All right. So now let's go to our middle interval here between -2 and +2. We chose 0. So everywhere we see an x, we're going to plug in 0. So I have 0 + 2 in the first parenthesis, 0 - 2 in the second parenthesis. So then end up with negative times 2 times -2. So then that ends up with -2 times -2, which is +4. So we say, okay, well, that turned out to be a positive. So we said, okay, well, then between -2 and +2, we'll get a positive. And by the way, you could choose any number between -2 and +2, and you're going to get a positive value. You won't get a +4, for example, but you'll get a positive value. Now I'm choosing something to the right of +2. I chose 3. Go to my function. Everywhere I see an x, plug in +3. So I have 3 + 2. 3 - 2, so I have negative times 5 times 1. And then that will land us at -5. So we're getting a negative there. Now, for our final answer here, because you'll notice that I'm going to come down here and write it for us. We wanted where this function times x - 2, we wanted where it was greater than or equal to 0. So that greater than or equal to 0, since you say greater than or equal to, we are looking for the positives intervals. So picking my positive interval, that only happened one time, and so that would be from -2 to +2. Bracket on both. That's your final answer. Okay, so if this had been less than, I would be choosing the negative intervals, and I would choose the one on the far left and the one on the far right with a union in between. Okay. I'm going to let you try example 4 on your own. Let's see what I was doing there. And then let's move over to example 5 and 6. In example 5 and 6, these are rational functions now that we're going to look at in terms of where is our function less than or greater than 0. Okay, less than or equal to, greater than or equal to 0. Okay, let's do example 5 here together. So same rules essentially apply, that if I'm above the x-axis, I'm positive. If I'm below the x-axis, I'm negative. So hopefully you would agree that this whole portion up here, these are all positives. And then up until I get to this 2, those are all negative. But then on the other side of that 2, I am positive. Okay. So now in part A, where is my function? Where are my y values less than 0? Where are they negative? So hopefully you would agree that they are negative. Now, they're negative from, pay attention to your vertical asymptote, from -2 to +2. Okay. In letter B, the only difference is here it says where you less than or equal to 0. Now notice how the -2, here this -2, that's a vertical asymptote, and this +2, that's an x-intercept. You can't equal a vertical asymptote, but you can equal an x-intercept. So the parenthesis is going to stay on the vertical asymptote, but you can put a bracket on the x-intercept. So you can bracket, I'll write that note for you, bracket x-intercepts, but not vertical asymptotes. Okay. In letter C, it wants to know where is our function greater than 0, where are our y values greater than 0, where are y values positive. So we are positive from negative infinity to that vertical asymptote. So negative infinity to negative 2. And also, again, from 2 to positive infinity. And then lastly, in part D, it's essentially saying the same thing, except this time, anywhere I have an x-intercept, I can change that into a bracket. So that's going to allow me to take that positive 2 and put a bracket on it. Okay? I encourage you, pause the video, try example 6 on your own, make sure you're tracking with that. Okay? And then we'll move over into the last example, which looks at a inequality. So here's the inequality, and I'm looking for where this inequality is less than or equal to 0. Now the only thing that'll be a little different with this one is that you've already kind of seen it whenever I was talking about it on the previous page, difference between vertical asymptotes and x-intercepts. Here you'll notice that you have a vertical asymptote at negative 2, so your x cannot equal negative 2. So if I think about a number line, in 171 you're going to hear me call it a sign line. At negative 2, since that's a vertical asymptote and you could never equal that, vertical asymptotes will always get open circles. And then another portion, because remember everything up here was positive, and then after that vertical asymptote things became negative until we got to the x-intercept. And then on the other side of that x-intercept, we became positive again. So turning points then happened at your negative 2 vertical asymptote. I'm just going to put VA underneath that. And your positive 2, which was, I'll put underneath that, this was an x-intercept. And that can be a closed-in circle because here we are looking for where you are less than or equal to, so where you would equal that. Think about now my intervals. My intervals then run here from negative infinity to negative 2. Negative 2 to positive 2, parenthesis on the negative 2, bracket on the positive, and then 2 to infinity, like so. Choose values in each of these intervals. So I'm going to choose negative 3, 0, and positive 3. I am going to now plug these test values into my inequality. So I have 3, my rational function inequality, times negative 3 minus 6. Over negative 3 plus 2. So that gives me negative 9 minus 6 over negative 1, negative 15 over negative 1, so that lands me at a positive 15. And technically, once you'd establish that it's positive, you don't really even care what the number is. You just want to know if it's positive or negative. So I can come up here and say, okay, now I know that that portion is positive. Now I'll come in, I plug in 0. So I say 3 times 0 minus 6 over 0 plus 2. Negative 6 over 2, that'll give me negative 3. So that portion is negative. And then in the last interval, 3 times positive 3 minus 6 over 3 plus 2. So that gives me 9 minus 6 up top over 5. Gives me 3/5. So we find that that's positive. Here we are looking for, since our function, I'll write it down here, 3x minus 6 over x plus 2 says less than or equal to 0. So since we say less than or equal to, we are looking for the negative intervals. So it just makes sense that if you're greater than, you're looking for the positive intervals. If you're negative, you're looking for the negative intervals. Oh, goodness. If you're greater than or equal to, you're looking for the positive intervals. If you're less than or equal to, you are looking for the negative intervals. I had one thing in my head and saying something different. Sorry about that. All right, so since this is less than or equal to, I'm looking for my negative intervals. Let me write that out. Negative intervals. And that only happens in one instance here from -2 to +2, parenthesis, bracket. Okay? All right, well, hopefully, like I said, this will give you a nice introduction then to whenever we start stepping this up a notch in your 171 class. All right? Thanks a lot. Let me know if you need anything. Bye.